Okay, while setting up, please give me some update.
Yeah, update. We did on Wednesday we did physics.
Yeah.
I think we got we continued nuclear physics and we got all the way until like the fun power radiation. So introducing like alpha,
which
beta,
radiation?
gamma.
Which radiation?
Alpha, beta, gamma. Like they introducing.
Right.
They haven't reached the differential equation yet, but I think he will next week.
Okay, good. So at least lecture once. Okay, good.
Yeah. Was it math? Yeah, I mean math was like lecture. Lecture we continued the hypothesis testing.
Yeah.
So like p-value and critical region, all that stuff.
Right. That is the almost the final thing. Right. That's almost.
Is it? I mean, maybe, but it was like what? It was an hour. Okay, whatever. And then for chem we finished. No, we didn't finish. Did we finish? No, we didn't finish nitrogen compounds. So we continued. Chem we got the Ca2 back, and it's not good.
Right.
I got a 12 out of 30.
12 out of 10. All right. Remind me the topic again.
Halogen derivatives and theory of acid bases and hydroxy compounds.
All right. As per usual, send me the picture immediately so that we can analyze.
Yeah. So we'll continue. I think we'll finish nitrogen compounds tomorrow, and then electrochem will start next week.
Electrochem. Oh, okay. We have
the tutorial. Lecture wise, I think we've gone through electrolysis.
Electrolysis? No. Why would you go through electrolysis? Sorry.
Lecture for the lecture.
You mean the electrochemistry chapter contains electrolysis?
I mean, it's easy to show you.
We were talking about cell, the reverse of electrolysis.
So
the reverse of electrolysis.
After cells, there's electrolytic cells. I guess this is still electrolysis.
Okay, so again, waiting for the connection. Okay, that's better. Yeah, electrolytic cell. So the cell is battery lah. Electrolysis seems to be later, right? This is that's electropotential, this is electrolysis. Yeah, but the moment you talk about electropotential, that is definitely cell. Yeah.
And then there's this one. Faraday constant, and then of course the second law.
Then we have electrolysis. True. Now this is electrolysis, true. So you are here. Oh, we should have talked about this. Right. Yeah, and then this is from O level. Yeah.
Yeah. They finished it in one lecture. But I'm going to look at the SLS because he said it's on condensation.
Right.
So
okay. Understand. Right. And that would be there's still tomorrow, right? Because you started.
Tomorrow there'll be chem, just tutorial for chem.
Okay. So any honest question on the tutorial first?
There's one on electrochemical cell. It's not oxidation, but a disproportionation in reaction. They didn't really go through this well, so I don't know how to construct it. This is 12 part 2.
Today is 5th.
Yeah.
Just let me copy. 12, is it?
Yeah, 12 part 2.
Right. The last elucidation, the one that I'm not sure, have you discussed about that?
We haven't discussed it in class yet.
Okay, I understand. Right.
I guess I'll do tomorrow.
Okay. Okay, so 12. Okay, I'm reading it very quickly. Okay, sure. Right. Okay, the oxidation number is there, right? Because you have -3 minus. Oh,
This one I'm just following
obviously,
what the
obviously
yeah.
minus, yeah. So -3, -2, and then there's a +1, and then you average it. It's just simple math lah. So you take all
Yeah,
of
that
them
I got
divided
it.
by 4 lah, right? Okay,
Yeah.
so then the balance equation. So what is the question actually? Part 2, is it?
Yeah, disproportionate reaction. It
Right,
contains only
okay.
CH4 and CO2.
Yeah, yeah. Okay, so construct a balance equation. So this proportionation, and obviously because CH4 is the most -1, you know that now, and CO2 is the most +1, right? Okay, so construct a balance equation.
I assume this proportionation is the C must both reduce and oxidize.
Yeah, but that's just moving on from the butanoic acid, which you have here on the left-hand side, and then the right-hand side, you just have to write down CH4 and CO2.
Yeah, but
So
I don't know how to equate them with only CH4 and CO2.
You balance them, I suppose, yeah. So, okay, so I've never seen or do this reaction before. So I'm just going blind based on what he's telling me, right? So again, what I'm doing is I'm just writing this on the left-hand side, right? Again, Jamboard page 12, yeah?
Yeah.
Okay, so I'm just writing the long one just to help me think, because I'm not certain what's going on here, right? I'm not really certain, but, just to help me think also, this will be C. Okay, I'm going to do this. I'm going to do something weird. This is C3H, I believe 8, right? And then CO2 lah, right? This is rarely written here, but the problem is I don't know what this is, so I'm just going to write down that thing. And then this is CH4, and then this is CO2 lah. Okay, right?
Okay.
So there are 3 question marks here. I just put them just to help me think. There's the box.
Or you can add something. I thought.
That's the part where I'm not 100% sure. So I'm giving myself a question mark, right? Can I or can I not? Because if I cannot, that's actually simpler. I like it. I like it better than. So because I don't know the reaction, right? Aqueous, he even bolded the aqueous butanoic acid. So I feel like, is he trying to hint me or something?
Like water.
Right? Yeah, like, is it water that you want me to? I've never seen the reaction of butanoic acid with water. Can an acid react with water? I mean, weak acid lah, reversible reaction lah. Is that what's going on here? I don't think so, right? I really don't think so. But yeah. So I'm just thinking aloud. Yeah. I'm reading. Yeah. The fermenting bacteria gains energy by metabolizing organic compounds. So a series, some more. Wow. Series of this proportional reaction that is expected, from which form methane and carbon. Oh, how interesting. Right. Oh, very interesting. But that does happen. Yeah, I like it. Now, he tells us it's anaerobic. So I'm going to write down a few things. So just to help me think, this is definitely not going to be plus O2. So he has to derive it from something else, right? But there is nothing else possible. There is really nothing else possible. It's just aqueous butanoic acid. There is no other option given by the question. So going in blind, right? Going in blind, I'm going to put H2O lah. Again, I'm going in blind. Fully going in blind. Just following what the question is telling me, not even sure whether I'm correct. So now things is a little bit complicated, because as you can tell, the O is on 2 things here. Sorry, this goes back to O level. I'm just balancing, right? Balances are supposed to start from one thing, that which has only 1 here, and that which is only 1 here. Now, what do I mean by that? The left-hand side contains 2, the 2 item in the left-hand side contains O. That complicates things. The 2 item on the right-hand side contains C. That complicates things, right? However, and the two item on the left-hand side contains H. Dang, there is nothing simple in this balancing. Do you understand what I'm saying? Nothing is simple because it's all spread out to 2. We cannot start with anything. You understand what I'm saying? Right?
Oh, is it just like 1 and 1?
1 and 1, yeah. We should always start with 1 and 1. In fact, if there's 1 and 1, the rest is easy one. This is 2, 2, 2. Hi, I want you to know this is difficult mathematically, not chemically, right? It's just a mathematical problem. So what do I do? Okay, let's say I cannot think. I use the most brute force method ever. A, B, C, D. This is the most brute force method ever in terms of math. We don't guess already. We just do algebra. Okay, so again, again, just to help me think, this is C4H8O2, right? Which is what you have written. So again, in terms of C, I'm brute forcing, right? So A, 4A must be equal to 1C plus 1D, correct? In terms of C, right? So nothing is going to happen from there. This is how, when you see this in math, you realize how complicated it is. Okay, what am I supposed to start with? Well, nothing, right? Nothing. But we continue and we press on. So the H, so 8A plus 2B, right? Needs to be equal to 4C. Okay, correct or not? So simplified, 4A plus B equals to 2C. Again, nothing comes out of it, obviously. So that's the H. Now, you help me with the O.
So that's 2O, no, 3O.
2A, what are you talking about? 2A.
Oh, 2A.
Yeah, there's an A there. You don't say 3O. Wrong. 2A.
All right, 2A plus 1B.
Yeah, 1B must be equal to
2D.
2D. Right? And again, this is how we see. Okay, my goodness, nothing comes out of this. There is no 1 and 1. There's 2, 1, 2, 1, 2, 1. So complicated. So we just have to, simultaneous stuff, right? So I'm going to ask you to start looking at this as a math problem. Which one should we start with? We should be combining two things.
Give me a sec. B and B, so H and O. So remove the B.
So which one? So the H and O, right? So these two. Okay?
If we remove H and O, then we have A, C, and D. Okay, H and O first.
So these two, what do you want to eliminate? What do you want to eliminate?
The B. So
okay, right. So minus lah. So I'm going to say 2 minus 3 lah. So just to help us track, 2 minus 3, you will get 2A on the left hand side equals to 2C minus 2D. Okay, and therefore A equals to C minus D. Okay, that might be helpful, right? At least it's simple, correct?
Yeah.
So we have to continue lah. Then what else?
We sub the A into equation 1.
Well, then we can get 2 equations. That's not bad.
I mean, yeah, but you just get C and D.
A. No, it'll be 4, right? So again, oh my goodness. Now you can press calculator. No. Take out your calculator. Sorry.
Graphing calculator?
Yeah, the fancy graphing calculator which can do 4 simultaneous, 4 unknowns to me. 4 unknowns. Come on, you know this. This is the first topic. I don't think I can use it in chem, but you cannot use this in chem.
No. I mean, I don't bring it to chem. I'm not sure if I can use it.
Okay, that's definitely a question. So simultaneous equation is 4.
Equation is
no, we're gonna have 3. I'm sorry, we're gonna have 3. Unfortunately, we have 3, but we have 4 unknowns. Right, and then we have to format it as this minus this minus. Okay, so 4 0 minus 1 minus 1, right? 4 then 0, right? Then minus 1 because you're moving it there, right? You have to
Oh
to
my
the
gosh.
left-hand side. Yeah, it's like
Minus
this is
one.
new to you. No, it's not. Yeah, it's not. -1 minus 1 equals to 0. Okay, so that's the first one. This one, 4, 1 minus 2, 0, right?
4, 1.
4, 1 minus 2, right? And then
There's a
0.
B, right? So
Yeah,
1
1 minus 2.
and C is minus 2.
And then 0, and then equals to 0. So then last one is 2, 1. And then
2, 1, 0.
yeah, and then moving here, -2, and then 0. Okay, so let's see first. So what does this mean? So D is D, right? Okay, this happens a lot. So whatever D is lah. So you feel free to set, he's saying to you, whatever you set D, the rest will follow, right? So in the interest of making everything nice number, because we have to, I will set the D as 3, right? I will set the D as 3. Then everything else falls to place lah. This will be 5. This will be 2, and this will be 2. That's how to interpret this result. Do you understand?
Oh, I guess that works.
Yeah.
I mean, that has to work, right?
That has to work because chemistry cannot deal with fraction. Well, you can at the mathematical level. Then you have to make it nice. Let me emphasize that guessing 2, 2, 5, and 3 takes a lot of work. Doing 4 equation and 4 unknown takes a lot of work. I don't care for now. I don't care. I just want to know whether my guess is correct or not, because I'm very concerned that my guess is not correct. That's my concern, right? So again, this is the result of my guess. Let's check the answer key, see whether it's correct or not. If there is,
that's not the key. It's a tutorial.
Then for now, it's like that. That's the best answer I can offer the question right now.
Okay.
Remember how I do it? I go in just by reading the question and trying to understand the hint. That is all I do. And I acknowledge the difficulty mathematically. I acknowledge that. I don't like the math. I don't like the math, but therefore I acknowledge the difficulty. There is no shortcut, just to be clear. There is not. Okay. So there you go. There you go.
Okay.
Better give me a lot of marks. If he doesn't give me a lot of marks, and I already know by experience the math might be difficult, I'm just going to buy by this in A level at the start. Probably I'll do it at the end. No? Just to be clear.
All right. All right. Right. I don't have any like.
Sorry, you have never done this mathematically.
No,
because it's challenging. That
I
means
think like I did very simple ones in like a J1, but like nothing this complicated.
Yeah. So even in O level and J1, there is an implied thingy. There is always the one guy and the one guy. Yeah. That makes everything extremely simple. Once you don't have that, there is no other way out. This is the way to do it. I mean, you can guess lah, but that's just shooting in the blind. Right? Okay, shooting in the dark. Okay, so next question.
Right. I don't really have like actual like proper question, but more like lecture. Like,
yes, please. Yes, please. Finally, you're asking. Good. Good. Finally, you're asking. Finally.
It's very I don't know how to say it. Very odd. Because there's a lot of like.
Yeah, the formulas are not going to help you because the formula is there already. If you understand them, you can use them already, just to be clear. Okay. Now, let's go to the standardized. I need you to understand the standardization. If you don't understand the meaning of standardization, if you think it's a formula, well, then if that's the case, your problem is solved. If that is truly the case, right? So I need you to understand what standardization. I want you to flip to the lecture note when you first have standardization.
Oh, that's a while back.
Yeah, I think that we understand that. We understand it. And if you don't understand the why, nothing is going to happen.
There you go.
9, standardization. When you first set the mu to 0. Yeah, nice. Okay, blah, 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 blah. This Z, this big Z thing. Okay, good. Yeah, I'm going to say to flip to the next page. I'm looking for something here. Okay, the first work example. Let me see down. Let me see the, okay, let me see the work example 6. Let me see the work example 6. There you go. Okay, look at that. Look at that. Immediately after they talk about standardization, immediately they give you a situation, a normal distribution where you do not know the mu. They ask you to find the mu immediately. Now, let me ask you something. Do you know this already? Do you know that the standardized normal is always used when you do not know the mu, or you do not know the standard deviation, or you do not know both? That is definitely the time where you use standard normal.
Because they give you a mu and standard deviation of 0 and 1.
That's not the reason. That's not the exact reason. Because you have to flip between the original and the standardized. And the standardized is the way for you to do things, and then you have to flip back to the normal. So there is, meaning to say, there is no way to do it in normal. There is no way. You go to standardized and then you move back to normal. You have to understand the movement. That's the main reason why you have to use it. There is no other way. There is no other means. There is no other formula.
All right, all right.
If you understand that from the start, you will put a lot of effort there, because most questions are like that. Most are pure normal question. They don't give you something which you know both the mean and the standard deviation. That's why I can get it. Now, if I ask you to close work example 6, can you do it?
Probably not.
Problem.
The formula is
no. I'll give you the formula. Can you do it? If you cannot, that's the big problem. It's a very big problem. Okay, close it with your paper. I'll give you the formula. I'll try to explain. You need to understand this. Let me say that you need to understand what's going on here. There is, yeah, no other way. Okay, so close your work example 6. You have to see the question. You have to see the question. You see the question of work example 6, and give yourself a paper, and then let's do it. You need a piece of paper to cover the solution. Okay, any paper, anything, anywhere. Right? Okay, you need to see the question also, so you cannot just cover everything. Right? Okay, good. Yeah, that will be nice. Okay, now let me give you the formula, and I'm forcing you to remember the formula. It is extremely simple. Look. Don't know what equals to. Okay, very simple. The difference between the mu, the original mu, right? Original mu, right? Minus something, don't know what, over the original standard deviation. Okay. At this point, do you understand when I say original normal distribution?
I mean, original is just like the one they
give you usually. That's the situation. Yeah. So you're taking the original guy, which you don't know in this case, minus something, don't know what this is, over the original standard deviation. Right? Now take a peek in the formula. Tell me what these two things are. Take a peek at this formula and tell me what these two things are.
Flip to the formula.
You can if you want to. Don't look at the working. Just don't look at it. There you go. No, you're here. You're here. Right. Here. So what is this and what is that?
So if this x minus mu, then that's.
Oh, wow. So this is not appropriate. So it should have been, who is this guy? Again, who is this guy? What is that? Equals to, who is that guy? What is that? Minus mu.
That's fine. The x is the original, I guess.
Original what? Original what?
Original normal distribution. Sorry, original. I guess it's the function at the beginning. I mean,
No, let's stop there. Let's stop there. Give me a random mu and a don't flip, no point. Okay. Give me a random mu and a random standard deviation. I'll construct a normal distribution for us. Okay, give me a normal. Give me a random.
Five and 3.
5. So 3 lah. So what does it mean by 3? Again, the meaning should be very clear to you.
Right.
8 and this is 2, right?
Yeah.
And this whole thing will cover how many percent roughly?
70%.
Yeah, almost, almost 70%. And then if I go -1 and then I go 11, then this thing will cover
almost 100, like 99.
No. That's the third standard deviation. That's the third one.
Oh,
the second one is not around it. Around
I was at
95%.
95.
A lot, quite a lot. Then the third one, what is this number?
Yeah, 99.99.
What will be the number here?
99, but
what will be the number here?
that will be 1 minus. I gave -3, right? So the -4.
Yeah, -4, and then this guy will be 14. 14. Did I do it correctly? 9, yeah, 9. Yeah, okay, correct. So this whole thing will be 99. So basically almost everything, right? So that's why they use 3 standard deviation as kind of like, yeah, beyond that, there isn't much to talk about, right? Beyond that, right? Unless you're talking about something very extreme. Back to the question, who is X and who is Z? I like what you're saying. X belongs to the original guy. So in this situation, give me an example of X, please.
I mean, is X the percent or is X the number?
Okay, let me give you an idea. Let me give you an idea. This X will minus the mu. This guy is like the difference between X and mu. So will it be percent? Will it be something else? Can it be both? What do you think?
I don't think it's percent.
I don't think so
percent
too.
is what you get out of it.
Oh, not necessarily. Percent is what you get from your calculator.
Okay.
The formula doesn't give you percent at all. This manual formula, nothing gives you percent. Nothing. Your calculator gives you percent. You're dependent on your calculator. This formula does not give you percent, I guarantee. So give me an example of X. Give me.
Yeah, 6.
Okay, 6. Nice. 6, right? 6. I will give you another example. Just so happen, I put it as 8. Just what happened. Okay. Now, watch me do the transformation. This is the original, right? And this is the standardized one. Standardized, right? The standardized. The transformation of the standardized is very simple. You have the same exact shape, but the guy is 0. Okay. The mu of the standardized version is always 0. Am I correct?
Yeah.
Okay. Now, tell me, what does 8 become in the standardized version?
8.
Yeah. What does 8 become in the standardized version? If you have to think...
It becomes 3.
Oh dear. Okay. 8 minus 5. So 3. Yeah. Over 3.
Over, oh,
over
1.
1. The fact that you have to think about this means you don't understand the standardized version. 11 becomes 2.
Oh.
14 becomes 3. Simple. The formula even says so. Simple. Very simple. Very, very simple. What does 2 become?
What does 2 become? 2 becomes
oh, you're thinking.
-1.
Yeah, very good. I like it. I like it. -1 becomes?
-2.
Yeah, and this becomes -3.
-3, yeah.
Okay. So now, 6 is not a nice number. Like a similar experience with the half-life, right? You know, sometimes we get nice number, sometimes we don't. If we don't have a nice number, we have to think a little bit more. If I see 8, that's a nice number. No need to think 1 lah. But if I see 6, I rely on formula, right? So 6 becomes what? So 6 becomes 6 5
3
1
+1 third.
1 third. Okay, now I'm gonna give you a challenge. if you press the calculator to find the percentage, right? So we're going to find the percentage of this guy. Okay. Can we do it in the original, or must we do it at the standardized version?
We must do it in the standardized version.
No, we can do it in the original version. We can. Why not? Why can't we? We can.
I mean, yeah, I guess you have the mu and the
Because we have the okay. So now I'm gonna press in the standardized version. You're gonna find this percent. How are you going to do it? Please show me your calculator. Yeah, just to confirm that everything is okay.
So
okay, nice. Right.
Uh,
Right. So you're gonna use inverse norm, I guess lah. Huh?
So I need the
no
wait, inverse, isn't it?
No, you're not gonna use inverse norm because they ask you the area. So you're not going to use inverse norm. What are you going to use? You're going to use norm.
Right. So
normal CDA. Oh yeah, normal cumulative. Sure. So
the lower limit is 6.
Sure.
Upper limit is 1 times 10 to the power of 99.
Yeah. Not very nice to write, but that works. Yeah. The mu is
so 5 and 3.
Okay. Right. And the answer will be almost, let's call that 37%. So this is 37%. So think about this for a while. Visually, does it make sense to you that this is 37%?
Yeah, 70 divided by 2, 70, around 70. 70 divided by 2, that's like.
Why is it 70 divided by 2? Sorry, why is that 70 divided by 2?
Because like the first standard, I don't know.
This is 70%, okay? This is 70%. That is 70%. Like, how does that connect with this? Please visually, guy. I noticed that you're not doing this visually. You are not. You're not used to doing this visually. That's bad. This is 70%, kind of ish. Why is this making sense that this is 37%? Give me another reason. Your reason does not make a lot of sense.
I mean, other than it,
yeah,
going,
let's say it's 51%. Does it make sense?
51.
Oh, you take too long to answer. Oh my. You're nuts. Really. That means you don't see things visually. You're very focused on the formula. That's not the right.
Hang on. So wait, between the first and second standard deviation is like 20% increase, right?
Oh my goodness.
That's how I'm thinking about it right now.
This whole thing is 50%. This whole thing is 50%.
Oh.
Correct or no? Correct or no? It's symmetrical.
Yeah.
So if you have 6 on the right of 5 and you get 51%, you don't need to ask already. Must be something wrong.
Okay.
Make sense or not? Visually makes sense, right? Okay, so first thing first, this is at least lesser than 50%. So that's good. That's good, right? You may have to rationalize why this is 37%. Is that a good thing or is that actually a bad thing? Right? It might be bad, Yeah, I mean, you have to do this as a confirmation thing. Like 37% actually makes sense. Like you're cutting 30%. That's one way to do it. Does that make sense? You're cutting 13%, right? That's one way to say it. Does it make sense?
Yeah.
This is 13%. Okay, I mean, it's okay to me. This is a big chunk of the area. So I was thinking maybe it was less than 10, but you're saying it's 13. Okay lah, maybe lah. Another way of seeing it is, I know this chunk. Do you know what this chunk is? I know this chunk.
That is. Oof.
This is 70, right? This is 70, ma. So this is 35, ma. So this 70, this is 35, ma. Correct?
Yeah.
So what is this?
Wait, that's like 30% around there.
Wow, you chalat.
Oh no!
Wow, you very
no,
chalat. No, you're very chalat.
No. That's
You're very chalat. No.
That's not 5%, is it? No, it's not 5%.
Look, this is 35%. This is 50%. We're doing simple math. Come on.
Oh, 50 minus 35.
Yes, which is? 15.
15%.
Yeah, 15. Oh, so this is 15%. And the calculator is telling me this is 37%. Okay, that's much bigger than 15. I suppose. That's one way to say it. Another way to say it, this is 35%. And this is 13%. That sounds like a lot of sense to me. It does sound like it makes sense. That's how I would see it. This is 35%, and this is 13. Kind of 1/3 along the way. Yeah, kind of makes some sense. Definitely, I'm feeling very comfortable when I realize it. Look, I'm doing this visually and simple math. Does it give you some sense of things?
Yeah, I guess.
Okay, and you need this, I'm not sure whether the teacher emphasized this, but I see a lot of problems solved by simply thinking like this. Okay. Now let's go to the standardized version. Can you do this in the standardized version or you cannot?
I mean, I don't see why you can't.
Okay, please do that. Please do that. How would you do it?
What I do, like just 1/3 and then go lah.
Yeah, please do that. Please do that.
So lower is 1/3. Is this the same? Mu is 0. That division is 1.
Mhm. And just to confirm, you're not surprised that the answer is the same. You're not.
I don't think I am.
All right. So now, final question before you go to the back to that question. So, if I have the percent,
Yes.
if the question gives me percent, what am I supposed to do? Give me a random percent. Let's start with a random percent.
20%.
Okay, 20%, left tail or right tail or both tail?
Right.
Okay, right tail. So meaning to say this kind of area, right? This kind of area. Right?
Yeah.
So at this point, I'm going to ask you to visually estimate where 20% is. I really want you to estimate properly. Now, if you right tail 20%, where are we expecting our number to?
It definitely is. Okay, so that's the beginning is 35%. So
yeah, this thing is 35. Yeah. And this thing is therefore this thing is therefore
15.
Yeah. Where's 20
so
right there?
A bit to the left of it.
Yeah. And you have never done this before.
No.
Right? But this is extremely helpful. I guarantee you in exam. I guarantee.
And this is the same for like all normal
every normal question. Every normal question you can do this one. Like seriously, until hypothesis testing, whatever. It's normal, it's normal distribution. You can and you should think like this. Yeah. It's gonna be around here. That gives you a lot of comfort because you're basically thinking about their data. They're basically thinking about information. This is very similar to drawing the chemical structure in elucidation. Just shorter one. This is very short. Yeah, very comforting. I would say. So now, what do you do?
So I have the percent, then I need to find.
What would you find? The question, I never give you the full question, right? I just tell you, okay, 20% right here. Okay, then to me, it's extremely easy to guess what the question will ask of. Very easy to guess.
Like the number where it's 20%.
Precisely. So please do that just to confirm that you can do it. And then we'll go back to the work example 6. Yeah, all those things are correct. Good. And the answer is 7.5. Does that surprise you?
No.
It now gives you an idea, a meaning. Yeah, it should be 7.5. If it's 8.5, something is wrong.
Oh.
Correct or not?
Yeah.
Okay, makes sense. Now, we have not explained to ourselves why we need the standard guide. Oh, you will be needing it. I explained to you already. There's only one very simple reason. You don't have the original mu, original standard deviation, or both, right? Or both. they have to compensate. So what's the question maker's job if they don't give you, those things? They have to compensate by giving you more information. The information is usually in a form of percent. Let's go to work example 6. As promised, you don't have the mu. So they give you a percent information, correct or not? Do you realize that there's a percent information? That's an area information.
Yeah.
Okay, so what are you going to do with that? Can you immediately go original?
No.
You can't. How many percent is that?
That's 4%, like 4.78%.
Yeah, 5. Let's call it 5. 5%. Okay. So make a prediction in the standardized version. What or where is 5%?
Okay, so if the right side
is 15, right? This is 15, right? 15.
That's 15.
And
so,
what is this? What is that? Right? Like this is like 15, right? So 95, right? 95, right? So 95 is between here and here. 95 is between here and here. So what is this plus that? This plus that is basically 5%. Let's call this 95, like easier. So if kind of this tail, this small tail, and this small tail is 5%, then the only one tail is 2.5%.
2.5.
So where is 5%? Where
to the left of 11, but not
no, not 11, not 11, because you don't have 11. Currently, you don't have the original. Yeah, you don't have this. You don't have this. So the problem is, of 2. You only have original. Original is your friend, right? So on the left of 2, a little bit. That's your prediction. Yeah, but not before 1. Okay. Not before. So, not definitely not. Right. So you're very confident of this. In fact, I would say you're quite close to 2 instead of close to 1. That's my guess. Now you immediately acknowledge to yourself you cannot use original. Comfortably though. Now use the standardized one. Use the standardized. Better write the exact number. Yeah. 478. Yeah. Okay, nice. Right tail, right? Yeah, good. Right tail will be, read the question. Read the question. More than, so. Yeah. Okay, so 1.66. Okay, I'm going to call it 1.67. And is it according to your prediction? Yes. So and you should feel comfortable, right? You should feel comfortable. Now, I promise you the formula doesn't give you percent, right? The calculator gives you percent. That means if your calculator died, then you died in exam. Just want to say that you don't have to do this question, even though it's very easy. Just keep it. You're fully reliant on the calculator. Let me say this one more time. You're fully reliant on the calculator. Okay. All right. Now, what is the formula's job? I promise you, he only has one job: to connect the standardized version with the original version. Usually this way, not that way. If you already have the original, why bother standardize? Do you understand what I'm saying? Okay. Why bother? As you say, like in our imaginary question just now, you don't have to touch the standardized because you have the original. But now you only have standardized. So you need this formula to connect to original. Usually that's the way, not the other way. So please connect. How are you supposed to connect? So 1.67. Yeah, but you're going to use the complete number in the calculator, yeah? Right? Yeah. Yeah, that's a Z. Yeah. Minus, I don't have new. Nice. Over original standardized. Standard deviation is 6. Yes, excellent. And you have the new suddenly. Use the number from the calculator, the super complete one. Yeah, so it's 6. Yeah, and then 82 minus that. So bring that over, so 82 minus. Yeah. 82 minus that. 82. So 82 minus. So that would be 72 something, right? 72 something. Oh, no, that's the mu I'm talking about. This is 82, right? That's 82. This is 72. Okay, I'm just gonna lay down the standard deviation. Deviation is 6, right? So this should be what?
That should be 78 lah.
Right, and this should be
78 plus 6 is 84.
good. And look at 82, 84, the precision. Look at 2 and 1.67. Does it make sense? The precision.
Yes.
So your 72 makes sense, right?
Oh,
Now your working is only these 2 lines. I can even argue this is 1 line. Okay, plus the calculator. So 2 line, no, 1 line calculator, because you have to write down something. And then this is the second line. Now look at the work example 6 is the answer 72.
yes, it is.
Now, do you understand?
Oh,
The way it is presented can be confusing. I don't care. I want you to understand first. Do you understand? I'm not talking about the presentation. Your presentation is excellent. You don't get it. I'm asking you to understand the process, the thinking. It's not very complicated. Okay? The presentation you will learn. You're very good at presenting. I believe you in presenting. You're the king of presentation. I really mean it, you know. You will know the format one. Just understand the meaning. You'll be fine. Okay? Now, let's do a group example 7. Come on. Time is up, right? I hope not to your surprise, they don't give you mu and they don't give you standard deviation.
oh, great.
Great. So what does the question maker have to give you?
The
They have to
percent.
compensate you. No, they have to compensate you for 2 things.
They give you
So they have to
2%.
give you 2 kind of percent, 2 kind of information. Obviously, it's not it's harder than 6, but this is the hardest thing they can give you. Do you understand? That's it lah. They cannot take away more. They cannot compensate more. It's only 2 that they can take away from you. Understand?
Okay.
You're going to do this by yourself, and I'll see you on Sunday.
Right.
Let me emphasize one more time. You have to understand this. Everything else becomes easy. I promise you.
All right.
Okay. Now on Sunday, as usual, what's the expectation?
Questions. Yeah.
Yeah, but that's for the first 45 minutes lah. Then the other 45 minutes we'll still use to catch up, solidify the lecture.
All right.
All right. Now, but this question you will have to do, and if somehow you cannot understand by yourself, you have to ask this. Okay?
Yeah.
All right.
Yeah.
I'll see you on Sunday. Yeah.
All right. See ya.
Bye-bye.
Bye-bye. Oh, one more thing. Sorry.
Yes.
On Sunday it's Mother's Day, and we want to go and
Yes.
celebrate. So can we start tuition like 1 hour before that, 5 p.m.?
So what does that mean? 5 p.m. Yes, no problem. So 5 to 6:30.
Yeah, is that okay?
Yeah, definitely. That'll be excellent. Yeah. Please celebrate. Yeah, please celebrate.
Yeah. Okay.
Okay.
So I'll see you at 5.
Send me the the picture.
Yeah, the scam. I will.
Yeah. Bye.
Bye.